we learned in the previous lesson how to perform hypothesis testing in the case of the mean of samples drawn from normal distributions. When we make a decision, we can be in one of the following four situations. We can be in the situation where the truth is that H0 is true or false. And our decision can be that we accept H0 or we reject H0. So we can make the correct decision or we can make an error if we take the wrong decision. Therefore, there are four possible cases. In the case when H0 is true and we accept H0, we made the correct decision. In the case when H0 is false and we reject H0, we also make the correct decision. But in the other two cases, it's an error. So I want to see what's the probability of making an error. And we'll differentiate this error into two types. If we reject H0 in the case when H0 is true, that's a type 1 error. And if you accept H0 and H0 is false, that's a type 2 error. The way I remember them is probability of a type 1 is probability of rejecting H0 given that H0 is true, in the case where H0 is true. And probability of a type 2 is probability of accepting H0 in the case when H0 is false. We need to learn these two types by heart because they are not in our formula booklet. So we need to learn this by heart. Let's see how we calculate the probability of a type 1 and the type 2 error. But first of all, let's look at the graphical representation. Yes, I know, I'm a bit of a nerd, so I created this file in GeoGebra. I love GeoGebra. Let's see what the file does. So here is my working space, forget about it. And here is a normal distribution with the mean given and the standard deviation. So if I change the standard deviation, lower, higher, see how the shape of my normal distribution changes. And that's the significance level, which is 20%, 28%, and see how it changes here. So I leave it at a significance level of 1%, at 10%. Now, the point here gives me the area, so split the area into an acceptance region, where accept H0, and the rejection region. This is the area where I reject H0. And this one is at 10% significance level. This means that if I take a sample from the parent population and I calculate the mean, and the mean is on this distribution, then if my sample mean falls here, I will reject H0 because that sample is very odd. It's an outlier, therefore it's very unlikely that the claim is correct, that this is a parent distribution or the true distribution. If the mean of my sample is somewhere here, it means that it's very likely that this one is a true distribution. I forgot to mention, but probably it's already clear, that this is a one-tail test. Where H is, mu is 4.1, I just chose randomly, H0, and H1 is mu is bigger than 4.1. Let's see. So the probability of making a type 1 error, let us remind that probability of a type 1 error is probability of rejecting H0 given that H0 is true. So H0 is true means that H0 is true means that this is a mean, so this is a true distribution. So on this true distribution, so under H0, that's a true distribution, where are you going to reject H0? If your sample mean is bigger than this point here, so here is where are you going to reject H0. So the probability of rejecting A0, it's actually 10%, is the same as the significance level in this case. So it's 10% or 0.1 is the same as the significance level. On continuous distributions, probability of a type 1 is the same as the significant levels. We will see that on discrete distribution, it is not the same. So we saw what happens in the case when H0 is true. What kind of error we make, of type 1 error, when H0 is true, when the claim here is true, but we still reject it. So we create a type 1 error. Now let's see what happens when A0 is not true. So when the distribution, the true distribution, is not this one, but another one. So when H0 is false, then H1 is true. But I can't really calculate anything if I don't know what's a true distribution. So the question is to bring some more information. Yes, H0 is true. The true mean is more than 4.1. But what is it exactly I need to know in order to be able to calculate the other type of error? And that's what we're going to do on the next page. Okay, so let's see what happens. This one is the claim distribution, H0. And I assume that the true distribution is this one. So the true distribution is different. So if the true distribution is different, so the mean is different and is bigger, yeah, that's how it looks like. So the decision rule stays unchanged. Here I decide on the up to the green area that I accept H0, and on the red area I decide that I reject H0. So my decision rule stays unchanged. The type 1 error is still the red one because it's on in the case that when H0 is true. But the probability of a type 2 error, let us remember, is the following. So the probability of a type 2 error is the probability of accepting H0 given that H0 is false. Now, H0 is false means that the true distribution is the second one with this M1 now, according to my representation. So it's probability of accepting H0 given that the true distribution, which generally is a distribution of the sample means, is normally distributed with not 4.1 but 5.3 now according to my diagram, and the standard deviation is 0.6 squared. So I assume that in this standard deviation the size of the sample size was accounted for, and that's a distribution, that's a standard deviation after calculating the counting for the sample size. Otherwise I will need to apply the central limit theorem. So what does it mean that I accept H0? Remember that from the previous screen this one was acceptance region and this one was a rejection region. It still stays, is my decision rule. It stays from the previous part. So where I accept H0, where this x bar is smaller than, I don't see what's written here, 4.87. 4.87, oops. Given that this x is on the normal distribution with 5.3 and 0.6 square according to my diagram here. And now I just need to calculate this probability in any way you want and you can, by standardizing or using your calculator. So that's what I get. Therefore, the probability of a type 2 is 23.7% or 0.237. And remember from the first page that probability of a type 1 in this case was 10%. And it was here from the first page. So that's how I calculate the two type 1 and type 2 probabilities, which are errors in estimating. So these are errors in my decision making. Later on, we are going to calculate probabilities of type 1 and type 2 errors using different distributions. The process is exactly the same. You just need to make sure you make it clear for you on which distribution is your variable. then if you decide on which distribution is your variable, then you calculate the probability on that distribution. One interesting observation is about how these type 1 and type 2 errors are linked. So assuming this one is a distribution under H0, so under H0 that's a distribution, but this one is a true distribution in the case when H0 is rejected. So the red area is the type 1 error. Under H0, what's the probability of rejecting H0? The green area is a probability of a type 2 error. The probability of accepting H0, here I accept H0, given that H0 is false, so this is a true distribution. Now look what happened if we change the significance level. When we change the significance level and we make it higher, type 1 error increases and type 2 decreases. When I do the other way around and the significance level becomes smaller, type 1 decreases and type 2 increases. So the two of them are related. Now we'll see what happens if we change mean. So what happens if the true distribution has a higher or lower mean? And look what happens if the true distribution has a higher or a lower mean. An interesting question that appears very often is for what true mean of the population the type 1 error is the same as a type 2 error. Or sometimes they can ask if they give you the second mean, for what significance level is a type 1 error the same as a type 2 error. So I would suggest to stop the movie and think a bit and look at this diagram. It's a bit obvious when the two types of errors are equal, and this is when you have a symmetry. So just pause and think a bit. And now see, this is a mean of the first distribution, and this is a mean of the true distribution. So if you want the symmetry, then here the critical value where they meet must be the same as the first mean plus the second mean over 2. Or we call them mu, mu1 plus mu2 over 2. And this will be the value giving you the critical region. In this case, the two types of errors are equal.